All right, so Sergio's gonna go. He's got air conditioners. We were just doing a demonstration off to the side, and then I was reminded, like, oh yeah, I have to bring you guys into this. So Sergio is just getting started here. I think, is this it, Serge?
Yeah.
Yeah, okay. So if you wouldn't mind just maybe starting from the top so these guys could follow you. All right, so you'll have this guy here. And if you have to point to something, remember to draw on the screen. If you want to go to the next one, just touch it.
Oh, okay. So how does it work? An air conditioner draws heat energy out of the house and transfer it to the outside air. Where does the hot, cold air come from? Cold air comes from the absence of heat, and hot air comes from the heat energy. And here, there is like a diagram that explains it. Why is the air conditioner hot outside? Because it expels the hot air from inside the room to the outside. How does your air conditioner integrate with forced air heating? It is a complementary system, one for heating and one for cooling. And how does an air conditioner utilize thermodynamics? So an air conditioner works using a thermodynamic cycle called the refrigeration cycle.
Turn around looking at me. Can you tell, like, if you've got a question, direct it towards Sergio. Neither of us are mind readers. It looks like you're looking at us to read your mind. So speak your mind. Nobody? All right, continue on.
Yeah, that's the final.
Okay. So how does it work, Sergio? How does it work?
Oh, so the cold air.
Repeat my question. So people at home can't hear what I just said. So repeat. Mr. Hare asked.
Oh, Mr. Hare asked, how does it work? So
you draw on the board. Yes.
okay. So here comes the cold air towards the compressor, and then this is the hot air, and it's like a cycle.
I want to correct you here. May I borrow your microphone?
Yep.
So this inside of here, there is not, I'm gonna step here. Inside of these tubes is not air. Inside of these tubes is like the air duster thing that we saw. It is a fluid. And what you're doing is right here, you'll see the compressor. Here's the compressor. So you're compressing down that gas into a liquid. And so here it's a liquid. Oh, it's traveling this way. High pressure into a liquid. And then this is the that valve that I pushed, and it turns it into gas. So then you can let it evaporate. Oh, condenser. Okay, I'm sorry. I'm just seeing this thing. I think I'm wrong. Number one, you're not taking air from inside the house and putting air outside of the house. You're taking heat from the air. There's a compressor here, which does the compressing. And then outside the house, this is where this thing is getting hot. Remember how I told you the compressor is hot? That thing outside of your house is where you're doing the compressing. And then that fluid, it's called labeled a metering device, but it's actually a valve. Like me pushing that button on the air duster, you're letting it go from a liquid and turning it into a gas. And when you do that, it's absorbing heat. So you're taking in heat right here. So this is sucking in heat. And then you pump it back outside to turn it into a gas. And this is where it's giving off heat to the universe. So it's kind of like a heat mop in a way, where you're absorbing heat right here at the evaporator coil, where you're letting that stuff evaporate. And then when you compress it down and back into a liquid, you're giving that heat off to the universe. And a lot of times, this is why this thing has a fan associated with it, because you blow air past it to give that heat to the outside air. Nick had a question. Evan, sorry, I say that. How does the liquid go inside the tubes, go from a liquid to a gas without heat? It's absorbing, and the answer is it's absorbing heat from the air around it. That's why it cools, quote unquote. It's cooling. Oh, my air is air conditioned. I'm taking the heat from the air to make that evaporate inside of there. Chase has a question. Yep, it allows it to. So his question was, there's a valve that lets it change. So think of me with that duster, how I was pushing on the valve. That valve is on one side is high pressure, like the gas inside of the can. And when I open the valve, I'm letting it escape into a low pressure. And when it does that, it evaporates. And that's where it's absorbing heat. So there is a valve in here where you're letting it on one side of this metering device. This is a liquid. And then when you're going here, it turns into a gas, kind of like your propane grill. After it comes out of the propane tank, it goes from being a liquid inside the propane tank, and then it's a gas turning into it. And this is also the same reason why sometimes when you use your propane grill, there's frost that occurs on the outside of the tank. It's making fire, but how is it happening? It's absorbing so much heat because you're letting it go from a liquid to a gas. Lance has a question. So Lance asked a question, how does a compressor compress a gas into a liquid? You just squeeze hard enough and it becomes a liquid. Any gas under enough pressure can change phases and go from a gas to a liquid. Why? It's a question for Mr. Dressler. I think because of hydrogen bonds and yes, I'm not exactly sure why it goes from being a gas to a liquid, what causes that changeover. But yes, at different pressures, different things can become a liquid. Like liquid oxygen. Have you ever heard of liquid oxygen? Like the oxygen that we breathe, you can compress it into a liquid form. And so it's like almost, yeah. Anybody at home have any questions?
I don't think so.
Okay. I'll turn it back over to Sergio. Talk with the person right next to you. How this works in your own words. Go.
No, but it's a liquid. It's not a gas, it's a liquid. Yeah, but then it gets turned into a gas. We can put it cold. The little machine then it becomes compressed. But it's an air.
Okay.
Our next one is sous vide cooking. Make sure that you talk with that microphone too. Is there? Yeah, double click that. Make sure you grab that microphone because otherwise people will have a hard time hearing.
Okay. So basically sous vide cooking is like a form of cooking where you put the food in a vacuum sealed bag, like you seal it in a vacuum sealed bag, and then there's like a machine that it has like a kind of a probe thing that you put in a bucket of water that you put the food in, and it brings the water up to the temperature, like the goal temperature of your food, very slowly. So it cooks it like super slowly, and it's like impossible to overcook your food when you use it. It uses a heated metal coil. It uses mainly conduction. I wrote convection, but it uses mainly conduction through because it's like the water touching the food, I think. The advantages of sous vide cooking, it saves the flavor, like it keeps a lot of the flavor in and the color, and minimal loss of humidity, so your food will be like really moist, and it has a better retainment of nutritional value as well. Disadvantages, it takes a lot of time, so if you're like impatient or if you need the meal, like if you don't prep it early enough, that's pretty inconvenient. Also, some people say it feels too scientific because a lot of people like cooking for the enjoyment of it, and you just kind of put it in a bag and leave it.
Do you know how much, like, you say it takes too much time?
It can take up to like a full day, like 12 hours, depending on what you're cooking. So probably like at least 6 hours to cook a steak, probably. Some of the best foods to cook with the sous vide machine would be eggs, lamb chops, steak, carrots, stuff like fish. That's not great for it because it kind of falls apart. You can make a homemade one because if you buy a machine, they're pretty expensive. So you can kind of like MacGyver your own with a crock pot and you need like a controller thing, like a temperature controller that you can put on a box. You have to make like a box of wires and whatnot. I don't know. Like I already said, it uses conduction, but it also uses convection through the heated water. And the food only cooks as much as the water molecules around it, so it's good for people who aren't good at cooking because, you know, it's pretty much impossible to overcook it. That's all I have.
All right. Next, we have Sadie Olds. And Sadie, I believe you had the refrigerator. Is that right?
Yeah. Do you just want me to share my screen? Or?
Yeah, that's what I was thinking about doing, is having you just share. And if somebody has a question, I can kind of act as like an intermediary to repeat the question, and they can hear you here pretty well. So
Okay.
let me see. I may have to enable that.
Yeah, you do.
Give me a moment. Okay, you should be able to share now.
There.
Yep, we got it.
Hold on. Okay. Thermodynamics of a refrigerator. How does a fridge work? So fridges are like heat pumps, but they try to cool down an area instead of heat it. And they're taking away heat from the air, and then the area gets cooled. So how does this happen? The refrigerator does something called inputting work, which affects a coolant, which is already in the fridge, and it raises the temperature so it's higher than room temperature. And this is represented by W in, or work input. And heat flows from the coolant and into the room, which makes the coolant lose heat, and that's represented by QH. And then after that, the coolant gets bigger and expands, and it gets cooler than the room temperature. Than the temperature inside the refrigerator. And then the heat flows from the fridge to the coolant, which cools down the fridge, and that's represented by QC. And the equation to represent that is W in equals QH minus QC. So why does the back feel hot? The back feels hot because the refrigerator needs to vent out its hot air. This is called the heat exhaust, and it can be located either in the back of the fridge or at the bottom. And basically there's tubes inside the fridge, and the hot air is pumped out through those tubes. Does a fridge replace the air with cool air? So a fridge doesn't really replace the air inside of it. The hot air leaves the fridge, which cools it down. And that's basically it. So the motor inside a fridge is called a compressor. This is because it shoves out hot compressed gas through the tubes, which I explained about, that are at the back and bottom. And the heat exhaust, so that makes it feel hot. And then the gas changes to a liquid coolant, which works to cool the fridge. And that's just the process that I explained on the first slide. And then propane fridges. So propane fridges have ammonia and hydrogen gases in them, as well as water. This works by taking the heat inside the fridge and then putting it into an ammonia-hydrogen mix. The ammonia connects with hydrogen gas, and then it absorbs heat. While this happens, the ammonia becomes a gas again, and then the gas combines with water, and the ammonia and water form a whole different solution, and that makes the hydrogen go back to its original place in the fridge, and then the process just repeats itself. So how does this relate to thermodynamics? It relates to the second law, sort of, so that heat flows from hot to cold, but the fridge is actually the opposite because it's making the air go from cold to hot. And that's all I have.
I have a question. Can you jump back to a couple of slides where it talked about why does it get hot at the back?
Yes.
Yeah. Mm-hmm. And you said that it needs to vent the hot air. Can you talk to me more about that? Is it taking the air from inside the refrigerator, the hot air out of the inside of the refrigerator, and moving it out?
Yes, I think so. That's what I got from what I searched. It's just put hot air out so that the fridge is then cool.
So in refrigerators, and the same thing is true about air conditioners. So I'm speaking to the whole class. It's not taking the air out of the refrigerator. It's not taking the air from inside the house and putting it to the summertime. It's taking the heat from the air. So this is what makes refrigerators really dangerous to little kids. You go in there and that seal around there, it's airtight, no air. You can suffocate inside of a refrigerator or a freezer. Little kids play in them. I think there's some sort of law that prevents it from locking. Old school ones used to have a lock. Now if you're on the inside of new ones, you push and it just opens. But you can suffocate. It's not taking the air out. It's taking the heat out of the air. Do you guys have any questions here in the class that I can relay? All right, thanks, Sadie.
Yep.
So you can stop sharing, and I am going to turn it over to Izzy. Are you up next? Is that right?
Yeah, I shared my video with you. if you
Sure.
could screen
Okay.
cap. And there's
Yeah,
two
I saw that
videos
come
because-
through on my email today. So I'll just share my screen and then make sure I'm clicking on the right thing here.
Sounds good.
Let's see. Okay, so there's two of them here. One is at like 12:58. Do you remember which one it is? The later one or the earlier one?
The first one I sent is the correct one.
Okay, so this one right here.
Yeah, I think so. Yeah.
Okay.
All right, so my
Now, can you guys, I don't know, sometimes you have to like optimize video for this. I don't know how to do that, but can you guys let me know if the video is not coming through on your end, virtual students?
Yeah.
thermodynamic appliance is the toilet. First off, I have the parts, and I'm going to show you where they're located. This
So can you guys hear that okay over there?
I can.
Yeah, I can hear
Okay,
it.
Yeah,
Like,
it's
I'm gonna
fine.
let her go then.
is the tank, and inside is the lift lever, the chain, the fill valve, the flapper, the overflow tube, and then over here we have the float. We also have the handle of the toilet. This is the bowl. This is the rim located under the toilet seat, and this is the siphon. So how do they work? There's two main parts of the toilet, the tank and the bowl. The tank is a squared shaped part of the toilet that is in the back, and it begins the flushing process. And the bowl is the part of the toilet that holds some of the water and the waste. The whole process of how the toilet works revolves around gravity. There's a hole at the bottom of the toilet that leads to a tube, which leads to the sewer. This tube is called the siphon, and it goes up and then curves down. When a large amount of liquid is forced into the bowl, it fills up so much that the water has enough force to push the existing water over that peak and down the pipe. So here I have a diagram. It's showing that this water is flowing up into the bowl. It's filling so much that it's pushing this existing water over this peak, and the gravitational pull is forcing this water down the tube. What happens when the lever to flush the toilet is pushed? So this tank holds about 2 gallons of water, and the handle that you push is connected to a lift lever inside of the tank of the toilet. The lever is connected to a chain that is attached to the flapper, and the flapper sits at the bottom of the toilet, and it's closed shut so that none of the water can get out. The flapper opens when you push the handle, and the water from the tank rushes into a channel under the toilet seat. The water flows through a little hole like jets cut in the rim. This is what you see when water rushes to the sides of the toilet after you flush. After the toilet is then flushed, the tank needs to be refilled. The water is brought back up through the fill valve, which is connected to the overflow tube. The fill valve is what refills the toilet after it is flushed, and the overflow tube connects to the bowl, which prevents the tank from overflowing. The float will float in the water that's rising until it reaches a certain point. The purpose of a float is that when it reaches that certain point, a pole that is connected to will stop the water flow from going to the fill valve, therefore stopping the water from filling the tank. So here I have a diagram showing that when the handle is pushed down, it forces this lift lever to go up, which forces this chain to go up, and then that will lift the flapper so the water can come out. When the toilet needs to be refilled after it's flushed, then the water will come back up. This is the float that's connected to the pole that helps it so it doesn't overflow. Will your toilet work if the power is out? So because of the gravity-based system, if it's a pump-assisted toilet, then you can still use the toilet during a power outage. Gravity moves the water and the waste down through the pipes and into the sewer with no power or electricity needed. However, depending on how much water is in the pipes, you may need to manually flush the toilet because the tanks won't fill up if the pipes are down. In order to manually do it, you need to take a bucket of water and pour it into the toilet bowl. On the other hand, if your water system is electronically powered, then you can't do this because the water and the waste is transferred into the sewer by an electric pump, so it won't work without electricity. Right here, I have the pump-assisted toilet, and this is a picture of the electronically powered toilet. This is the toilet that we're most likely used to. Next, I have the purpose of the S-shaped tube. So
Does this continue on the second video, I take it?
Yes.
Got it. Okay.
And you can like stop it once it's done because it takes a while for me to like stop the screen sharing.
Oh yeah, no problem. Yes, I'll save you.
All right.
I know how that goes.
okay, so the purpose of the S-shaped tube is that when the water is inside of the bowl, some of that enters the trap, and the trap maintains the water to keep the water at a stable level. This helps filter out the bad odors coming from the pipes. So as you can see, this is the trap seal, and this is where the water level stays stable in order for these bad smells to not come up through the pipes. And then I just have my resources. Thank you. Bad smells do not come up.
Do you guys have any questions? Evan has a question. His question was, here, I might hand the microphone over to him, and then I'll turn it maybe over to you, Izzy, and maybe you can answer it with this picture, or you could share your screen if you have like a diagram up or something. Here, I'll turn it over.
How does the toilet bowl empty completely of water when it fills up? If that makes sense.
Sorry, can you repeat that?
When the toilet bowl fills up with water, how does it completely empty itself when it's using the pressure of the water to like push it through the tube?
The water bowl fills up so much that it like forces the water down the tube and over like that peak that I showed, and like the gravity just forces it down the tube and into the sewer. I don't know if that answers the question or not.
Alrighty, that works.
It's gonna be hard for you guys to see at home, but I'll do my best. I've got a bucket of water here, and I've got a hose. And so what I'm gonna do, have you guys ever heard of a siphon? Yes. Can you guys hear me at home?
Yes.
So do you know what a siphon? Yeah, I've siphoned out gas, right? So what I'm gonna do, I'm gonna put this hose in here, and I can drain this entire container through gravity. Right, so I have this container, and then there's a hose, except I'm gonna put this hose, oh boy, asking for a mess. Chase, would you grab my beach towel back there? Are you ready? I just get it started. Once I get water over top of this, it's all gonna run out. Like totally gravity fed. Oh! Now, as long as this end of this hose is below, so watch what happens if I go above. It stops. Right? See how this is higher than the water? And then I go lower.
If you go lower, it'll point up.
Yeah, the lower it goes, the faster gravity pulls it.
Like what if it's lower, but it points up?
Oh, it would just bubble over like a bubbler. Yeah, like a water fountain. So thank you, Chase. Be careful to anyone presenting. It's a little bit slippery up here. Stop share.
So why does it keep going?
I'll explain it. I'll explain. Toilet diagram. Right here. So why does it just drain? How does it work? And it's all about this right here. When you put water into here and this water level goes up, because when you flush the tank, this water comes down and it raises the water temperature in the bowl, which is going to raise this water temperature here and not water level here, and it's going to flow around the corner. And once it flows around that corner, just like you saw here, the water, the entire contents get sucked out through gravity. This is what a siphon is. This siphon, it literally, when it's gravity pulling this down, will literally drain everything in the tank. Here's your assignment for tonight. I'm going to give you all 1 bonus point on the next test. If you go home tonight and you fill up a 2-gallon bucket of water and then just pour it right into your toilet and watch what happens. It will flush. It will make the same noise. It will do the exact same thing. You got to videotape yourself doing that. I'm going to put an assignment on Schoology that does that. So you got to videotape yourself pouring a 2 gallons of water, just dump it right into the bowl and watch what happens. Yes. Evan has another question. He says, what makes it keep going? What makes what keep going? Oh, why doesn't it keep going? So number one, this tank holds everything. So then you only are dumping this tank into it. And once it's done flushing, everything goes down and the tank refills itself.
No, I'm saying once like in the bowl.
Yep.
When water level is in the bowl, then that should
Oh,
go the curve.
yeah. How come it doesn't stop? It stops because the question is, well, when the water's in the bowl, how does it stop? Because it's not enough to go over that hump.
No, so the water is flushed, right?
Yep.
And then once the water level in the bowl like gets below the curve,
Yep.
it still continues like flowing through the curve.
Why does it still continue flowing through the curve when you fill up the bowl with water from a siphon? True. So like when water goes over this, right? So you have this slug of water right here. Gravity is going to pull this and it creates like a suction. And in physics, we talk about there's no such thing as cold. There's no such thing as suck either. There's a high pressure and a low pressure. There creates a low pressure, which pushes this down. And as this slug of water continues its way down the tubes, it keeps pulling this with it. Because otherwise it would have to create a vacuum or like this space of no air, which it just doesn't. It keeps pulling the water behind it. Have you ever done the thing with a straw where you put a straw in soda and you put your thumb on it and you lift it up? Like, why doesn't it leave? Well, because it's trying to, but that suction, quote unquote, it's trying to make a low pressure, which doesn't allow, like the atmospheric pressure around it is actually pushing it up. It's kind of complicated. Why does a siphon work? How does that work? It's totally gravity driven. And Izzy had a really good, how do you make toilets work on space station where there is no quote unquote gravity? It's pretty different. That's an interesting problem because believe it or not, toilets are the entire reason we have cities, kids. We would not have any cities if there were no toilets. It solves a really big sanitary issue. Like if you re-ingest things that come out of your body, like you'll get really sick and it's not good. Toilets solve that. Like we would not have any city on this whole planet if it wasn't for a way to get rid of that waste efficiently and cleanly. Okay. What's our last one? What we have well water. Who's our next one? Abby. You got 2 minutes. Is she here? You're right there. Yeah. Can you in 2 minutes explain to us how water towers work? Come on up. Yeah, we'll pick it up tomorrow, but let's get a start. You got a minute and a half. You get your 1 minute elevator pitch.
I'm not going to be able to get any of this done. All right, so I have the water tower and how it works. So basically, after like the water is cleaned and treated, it goes through a pump, which pumps the water up into a tower where it's held for the day. And every time like an area needs water, it's like the gravity pulls it down and pumps it out to wherever it's needed, like the area of the town it's needed. And then why do we need water towers? Because it distributes the water very effectively and a very cost efficient way. And then it will be able to work for a little bit without electricity, but the pump is electric, so it won't be able to pump new water into the water tower. So the water will work at a very low pressure.
We'll continue here tomorrow.
Maybe half of it.
Yeah, like it's incredible how quickly you really can get through these. No, you did a great job. Thank you guys for joining us. We'll continue with water tower tomorrow.
My house, so we're dumping 2 gallons of water into my toilet. Yeah, well, it just doesn't work. What if it spills everywhere? Not go down. So my mom would not be happy.
So what? The pipe going back to toilet? So if the pipe wasn't completely full. So if the pipe wasn't completely full, it's stinky. Like if the pipe was, yes. If there was a straw, if there was some way for air to get through, to make it through this, then yes, it wouldn't work. It wouldn't work. I'll show, I mean, here, let me show you a really cool little quick demo.
Library at this time.
I know that 7th hour guided study will report to the Commons today. Again, 7th hour guided study, please report to Mr. Robbins in the Commons. Thank you.
I'll write you a pass. Here, I'm just about to show you. It's pretty sweet. You guys see one of these? You guys know what this is right here? Yeah. Right? You flip this upside down. Right? It's going to take a while to do this. Now, if you can make an efficient way for air to get in there, right, give it a little bit of a spin. Right? Or chugging beers with your friends, with a straw like this, it'll go out quicker. So that the water wants to pull itself apart, but there's not enough to create. Like if you go underneath a boat underwater when it runs its propeller, they can turn so hard that they pull the water apart and like a void. It's called cavitation. Like, and this is what like submarines, they really try not to do that, because as you do that, as that water comes back together, it creates sound, and you can figure out exactly where a submarine is from cavitation on its propeller. So you spin it at a slow rate, so you want low rate, no cavitation, but you want powerful thrust so you can move quickly. So boat propellers don't care. You go underneath the water and you watch the slow-mo guys, they do this. They take a slow motion camera underwater and they show a boat propeller, boom, ramped up. You can watch that bubble form, and then it comes boom, and you actually see the shock wave. It's a bubble, but it's a bubble of a vacuum. There's no air in there. It's just you're ripping apart, making a vacuum, making a bubble of nothing. Yeah, so you want to do that. There's not enough force to create that bubble with what we've got, but you can. You had a long enough tube. Yeah. Can't you like make a seal already into that? What do you mean? Oh yeah. Oh, do you mean like the? Oh yeah. Yeah, like the straw thing that we. Yeah, because when you tip it, it's like. Do you mean like? Can I turn this upside down? Yeah. Without getting nothing out. And then like. No, I think if you pull your hand away, then no air can. There's no area where the air can go. There's a fun one. Do you guys know what wire gauze are? Wire what? Like you put it on remember when we melted our snow, that wire mesh? Yeah. This is crazy. You can take wire mesh. Like fill the water, put wire mesh on it, and turn it over real slow, and it will keep it. Like, because water is polar, it's got a positive and negative, it will attract that meniscus. So you can do it that way too. But can't you turn this upside down? And then, no, you might be able to if it was small enough, like that to make that meniscus, like cavitation, like it's the idea, like with a straw. Like you put this here. So this isn't going, but it's able. I mean, if I can seal it, I hold this here, but I'm like a little bit of air and come in my hand. Yeah. Yep. And that's the idea with the tornado too, like the high amount that it's a fluid, so the air is spinning, so it gives you a direct link from hot going right up. So it's a way. There's a temperature inversion. This hot air wants to go up there, and so when this gets spinning, it lets you go there, which makes that spin faster. It's this in the atmosphere. Like you're trying this stuff, air is trying to get up there, but it's got to go through the clouds to do that, and they call that updraft. You know what I mean? Like eagles, they do that all day long. They ride those, but if you get too much of it going, like with the big storms, like there's a lot of thermal up, and it's just too much. It creates rotation, and then once you get it going, then here we go. We get a little bit of rotation. Vortex. Where you guys headed?
I've got